Hello students, in the previous lecture we have seen the amplitude modulation and what happens in amplitude modulation, how the amplitude of the carrier signal is changed, and after that we have seen the expression for amplitude modulation. And during the expression, during the derivation of the expression, we came across a term called modulation factor. So let us, in this lecture, let us see the significance of that modulation factor, the definition and the significance of modulation factor. The modulation factor is defined as ratio of change of amplitude of carrier wave and the amplitude of original carrier wave. So this is the definition of modulation factor, and I have taken the modulation factor as mu. In some textbooks it's taken as Ka or capital M. There are many notations for this modulation factor. It is also called as modulation index. So the definition of modulation factor is ratio of change of amplitude of carrier wave and amplitude of the original carrier wave. To understand the definition, let us go back to the graphical representation of amplitude modulation and see. In the amplitude modulation, the amplitude modulated wave is of this form. So let us draw the amplitude modulated wave. So this is amplitude modulated wave which we are going to draw. So for drawing the amplitude modulated wave, you have to take a reference point above this one. Now we have to draw the envelope of amplitude modulated wave. To draw the envelope, we have to refer the message signal. The envelope of the amplitude modulated wave is nothing but the message signal. So let us say that the message signal has started from this point. This is the message signal, and we have to square it this side. So this is the message signal, and in this we have the amplitude modulated wave as. So in this part there is no modulation. So this is unmodulated. This one is unmodulated wave, carrier wave. So this part from here to here, this is unmodulated carrier wave. So but from here the modulation starts and the amplitude changes in this pattern. So this is how the amplitude modulated wave looks. Now let us see the things. So if you look at this amplitude of the modulated wave, here it reaches a minimum voltage and here it reaches a maximum voltage. So there is the oscillation between minimum and maximum. So from here to here, this point, so let us call this as V minimum. So that is V minimum, and from here to here, this is the original amplitude of the carrier wave. So this from here to here, so this is the original. So the amplitude of carrier wave, we have taken it as AC, and we have one more amplitude which is from here to here. So this is the maximum voltage or maximum amplitude of the AM wave. So this one, let us take it as V maximum. So this is how the amplitude modulation wave looks. So we have three amplitudes here. The V minimum, this is the amplitude, the minimum amplitude of the amplitude modulated wave. So we have AC. AC is the original amplitude of the carrier wave, and we have V maximum. V maximum is the maximum amplitude of the amplitude modulated wave. So coming to the definition of this modulation factor, so it is change of amplitude of carrier wave. So let us find out how much the amplitude of the carrier wave has changed. So in the previous lecture I have given an example. Let us take that the amplitude of the carrier wave is 10 volts and let the amplitude of the message signal be 2 volts. So the amplitude modulated wave will have a maximum amplitude of 10 plus 2, that is 12 volts, and a minimum amplitude of 10 minus 2, 8 volts. So this is how the amplitude modulated wave oscillates between these two voltages, the minimum voltage and the maximum voltage. Now if we want to see how much the change of amplitude of carrier wave, how much the amplitude of the carrier wave had changed. So initially it was 10 volts, so it has changed to 12 volts. So how do we find out the change? So the change is 12 minus 10 volts, that is the amplitude V maximum minus the amplitude of the carrier wave. So therefore mu can be written as V maximum minus AC divided by amplitude of original carrier wave, that is AC. So this is the one expression for modulation factor. So not only the carrier wave amplitude is changed to 12 volts, it's also changed to 8 volts also. So how much is the change? It's 2 volts. So this can also be written as mu is equal to AC minus V minimum divided by the original amplitude. So this is one more way of writing the modulation factor, either in terms of V maximum or in terms of V minimum. So if you find out this one, so V maximum minus AC. So for example, in this one, 12 minus 10, it is 2 volts. 12 minus 10, it is 2 volts. Okay. And again, if you see in this one, so it is AC minus V minimum. So AC is the 10 volts minus V minimum. So it is 10 minus 8, again 2 volts. So from this what we understand is V maximum minus AC or AC minus V minimum is nothing but the amplitude of the message wave. So that therefore mu can also be written as amplitude of the message wave by amplitude of the carrier wave. So these are the three expressions for modulation factor. So there is one more expression. So if you look at these three expressions, so this is in terms of original amplitude of the carrier wave and V maximum. This is in terms of original amplitude of the carrier wave and V minimum, and this one is in terms of amplitude of the message signal and amplitude of the carrier wave. There is one more expression which is modulation index in terms of V maximum and V minimum. We'll see that now. Now let us derive an expression for mu in terms of V maximum and V minimum. So if we look at the amplitude modulated wave, so V maximum, so this one, this V maximum, so this dotted lines is our message signal and this one is the carrier wave. So if you look at the V maximum, this distance, so if you look at this distance, so this distance is nothing but, so from here to here plus this one. So from here to here, this is the amplitude of the carrier wave and this portion is the amplitude of the message signal. So therefore V maximum can be written as amplitude of the carrier signal plus amplitude of the message signal. Now similarly, V minimum can be written as, so V minimum, so again if you see here this portion, so this is our V minimum from here to here. So this is the minimum amplitude of the amplitude modulated wave. So this can be written as So this height is the carrier wave. So amplitude of the carrier wave minus this portion, and this portion is the amplitude of the message signal. So V minimum can be written as amplitude of the carrier wave minus amplitude of the message signal. So these two relations we got. Now we will play with these two and we will derive an expression for mu in terms of V maximum and V minimum. So let us add these two expressions. So if we add these two, so what we get is, so here it will be V maximum plus V minimum is equal to, so this will go, so it will be 2 times AC. So therefore the value of AC will be V maximum plus V minimum by 2. So this is the value of AC. Now similarly, so let us take these two relations and subtract them. So we have V maximum is equal to AC plus AM and V minimum is equal to AC minus AM. Now let us subtract them. So here it will be negative, here it will be positive. So these two, this will become V maximum minus V minimum is equal to, so AC, this will go. So here it will be AM plus AM. So it will be 2 AM. So therefore AM can be written as AM is equal to V maximum minus V minimum divided by 2. So we got the expressions for AC and AM, and we know that mu is given by, mu is equal to AM by AC. So mu is equal to AM by AC. So let us take AM from here and AC from here, and if we divide both, so AM divided by AC, 2 will get cancelled. So what remains is mu is equal to V maximum minus V minimum by V maximum plus V minimum. So this is an expression for mu, modulation factor, in terms of V maximum and V minimum. So far we have seen, this is the third expression which we are seeing. The first one was mu is equal to V maximum minus AC by AC. The second one was mu is equal to AC minus V minimum by AC. The third one was mu is equal to AM by AC. And the fourth one is mu is equal to V maximum minus V minimum by V maximum plus V minimum. So there is one more expression, we'll do it later. And all these expressions of mu are very helpful in problem solving. So that was the expression for modulation factor. The next thing which we'll see is the amplitude modulation transmitter. So AM transmitter. Before studying the AM transmitter, let us see the significance of modulation factor and then go for the AM transmitter. The significance of modulation factor is, the first one, the modulation factor determines the extent to which amplitude of the carrier wave is modulated. So that is the first significance. It determines the extent, how much of carrier wave amplitude is modulated. The second one is it determines, or it gives the fraction. So what fraction of carrier wave is utilized in modulation. So it gives the information as to the value of modulation factor, gives the information as what fraction of carrier wave is utilized in modulation. So let me give an example. So suppose the original amplitude of carrier wave is 10 volts and amplitude of message wave is 2 volts. Then the modulation factor will be mu is equal to AM by AC. So that will be 2 by 10. So that will be 1 by 5. So that is nothing but that is 1 by 5. That means 1/5 of the amplitude of carrier wave is utilized in the modulation. So this is the second point. The third point is value of mu gives quality and strength of modulated signal. So the value of mu gives quality and strength of the modulated signal. So the value of mu can have three possibilities. One is mu can be less than 1, or mu can be equal to 1, or mu can be greater than 1. Mu is less than 1. So what it means? So mu is less than 1 means, so we know that mu is equal to AM by AC. So this implies AM is less than AC. That is, amplitude of the message signal is less than the amplitude of carrier signal. So if you draw this one, so we get this kind of graph. This is the envelope, and here we have the amplitude modulated wave. So if AM is less than AC, then what we get is, so if you do this one, V minimum, so V minimum will be AC minus AM. So AC minus AM, if AM is less than AC, then there will be some value here, V minimum, we get some value here. So what it means, if you look at this one, it means even if there is V minimum, this is V minimum, there is some signal in this part. So there is a continuous signal in this part. And if you go to the second one, if mu is equal to 1, mu is equal to 1 means AM is equal to AC. And if you look at V minimum, so V minimum will be AC minus AM. So if both are same, that will be 0, and the modulated wave will look like this. So at V minimum, so the value will be 0. So it will look like this, the modulated wave. The modulated wave will look like this. And if you look at the V minimum part, so what we find it, here the value is 0. That means at this point there is no signal. So here, even though the V minimum was there, there was some signal at this point, even though there is a V minimum of amplitude modulated wave, but there is some signal. But in this case, when AM is equal to AC, we find that at this point and again at this point there is no signal. There is no signal. Now coming to the next case, that is mu is greater than 1. So if mu is greater than 1 means, that means the AM is greater than AC. Value of AM is more than AC, and again it will lead to more complications, and there will be some phase distortions. All those things we will not go into detail. So just let us look at this one. So if AM is greater than AC, the modulated signal will look like this. So this is how the modulated signal will look if AM is greater than AC. So we can see here, that from here to here there is signal, but from here to here there is no signal. This part is called as distortion. So there will be no signal. So from this we understand that, from this what we understand is the value of mu determines the quality and strength of the amplitude modulated signal, and from our common sense we can understand that we don't want this kind of signal, because at some point there will be no signal. Imagine if you are listening to some radio and suddenly you will be having interruptions, so where there will be no signal, and here this is not at all desired because there is so much of distortion. So say for 2 seconds there is no signal, so it's not we don't want this one. And here this is the best thing, that AM should be less than AC. So in this part we have seen the significance of modulation factor, and you may get a 5 marks question like give the significance of modulation factor. So it's very important, this modulation factor, as far as quality and strength of the signal is concerned. Next we'll go for AM transmitter. Next, let us see the block diagram of AM transmitter, and this forms the end of this lecture. So before studying the AM transmitter, let us go back to the basics, the first lecture, and see the definition of communication. Communication means transferring or transmitting signal from one point to another point. So that is the basic definition of communication. So the signal, transmitting a signal from one point to another point. The signal can be anything. It can be audio, it can be video, or it can be a photo. So the signal can be anything. So the signal has to be transmitted from one point to another point. So we are familiar with audio signal more. So let me take the example of audio signals. For example, I want to transmit an audio signal from this point to point B. So whatever the audio signal is there, so it is it cannot be transmitted from here to here. It cannot be transmitted to a long distance. So this audio signal is first amplified. So it's amplified and then it is modulated. This is having very low frequency, so that makes it not possible to reach there. So that's why the audio signal is modulated. So in the process of modulation, what we do is we superpose a carrier wave, a high frequency carrier wave, with the audio signal, and we get the modulated wave. We get a modulated wave, and this modulated wave is transmitted through transmitter antenna, and at the other end, so this process is the modulation process. So here the modulation takes place and the signal is transmitted through the transmitter antenna, and now at the receiver end there will be the first device on the receiver end will be the receiver antenna. So then there will be a receiver, then there will be a detector or demodulator, and this signal is retrieved. So demodulation means retrieving the message signal. So the message signal, now in this process, so whatever the signal is going from here, this is the modulated signal. So modulated signal means it is having both the carrier signal as well as message signal, and when it reaches the receiver antenna, then it is passed through a receiver. The receiver receives it, then it is passed through detector or modulator. Here detector or demodulator. Here demodulation takes place. Demodulation means separation of the message signal from the carrier signal. So that process takes place here. So I think we have seen up to here the modulation process, all these things. So now this part is the next lecture. This part forms the next lecture. So the demodulation process. Now let us see the block diagram of AM transmitter. Once again. So let us say we have audio signal. So this is, we can call this as message signal. So this audio signal is amplified by audio amplifier. The frequency will be low, and now what we do is we put it on top of a wave which is called as carrier wave, and this carrier wave is generated by RF oscillator. It can be Colpitts or Hartley oscillator. So it generates a carrier wave of high frequency. So both carrier wave and the message signal are superimposed in the process called modulation. So this is the modulator. So now we get a amplitude modulated wave like this. So again, this amplitude modulated wave is not having enough power to get transmitted. So this amplitude modulated wave is amplified in power amplifier. Power amplifier provides sufficient energy for the amplitude modulated wave to be transmitted through this antenna. So it is transmitted through this antenna, and at the other end it is received by this. So this is the block diagram of amplitude modulated wave transmitter. So we come to end of this lecture. So in the next lecture we will see the process of demodulation, and then the receiver, the demodulator, and after that we will go for the frequency modulation.